Jai Hind all of you. I am Dr. Anand Tyagi from Ajay Kumar Garg Engineering College. Today I am going to deliver my lecture on Engineering Mathematics KAS 103T. Before it we have done some portion of the module 2 differential calculus first. Today I discuss here some most important topic based on module second, right. Module second differential calculus, right. First of all, contents of the today lecture are the derivative of a function. This is recall only because it covered in the previous lecture, right. Next is application of the Leibniz theorem. I explained Leibniz theorem in the previous lecture, but today I explain here what is the application of Leibniz theorem in our engineering as well as our daily life. Role of Leibniz theorem at x is equal to 0. That means how to calculate the Leibniz theorem at a particular point. Right. So, this is the main focus, how to calculate the Leibniz theorem at a particular point, and in the previous this is the for domain, and some example based on the above topic. So, first of all, and I explain the today contents are refer from the book AKGEC Advanced Engineering Mathematics, Marais de Weir, B.B. Ramanna, B.S. Grewal. Student can be adopt any one of them. Now, first of all, I explain again differentiation or derivative of a function. Suppose I have a function y is equal to fx, right. Y is depend on x here, right. How to? Because there are the two function, one is y is equal to fx and y is depend on x. That means x is independent variable and y is dependent variable. So, what is the role of derivative differentiation here? Right, that means dy over dx, right, fx plus h minus fx upon h, and limit h tends to 0, that is known as f dash x, right. Variable may be different here, right. There is not separate y and x always, right. There may be dv over dt, right, that means volume with respect to time, differentiate volume with respect to time, that means ds upon dt, distance s differentiate with respect to time. So, variable dependent and independent may be more than one, that means depend on our situation, right. Next, what is the definition? Because definition is the main phenomena. Change in dependent variable with respect to independent variable is known as derivative or differentiation. Y is dependent variable and x is a independent variable here. So, in this way we find the basic concept of the differentiation, right. So, we use such type of differentiation in our successive differentiation. In the previous lecture I explained what is successive differentiation, right. Now, Leibniz theorem, that is I explained it before lecture, right, and what is the role of Leibniz, right. First time Leibniz introduced the product rule of two function duv, first differentiation of first, second as it is, first as it is, differentiation of second. So, this is known as differentiation of product, but question is that how to calculate second time, how to calculate third time, and how to calculate nth time. That is the main motive of the Leibniz theorem, nth derivative of product of two. Suppose I have two function u and v, right, and I want to calculate the nth derivative of product of this function. So, how to apply Leibniz theorem? Question is that, right. So, u and v are the two person, we can say here, right. In the first time dn u, right, I write here into v, right. That means first of all nth derivative of first function and v as it is, plus I write here n, right, n minus 1 derivative of u into dv, right, and sum of both terms will be here n always, and in the next terms I write here plus n minus 1 upon 2 factorial 2 or 2 and dn minus 2, right, u, and second derivative of v I write here, right. All these things I explain again, right, by using this method, right. We can use the another form, this student use this because this is the easy task to solve our problem. and student can be opt any one of them, right? What is this, right? That means nth derivative of u and v as it is, right? N is in the Leibniz theorem, and then n minus 1 derivative of u and first derivative of v, and sum of both will be n. Each stage sum of both will be n, sum of this n, sum of this n, and sum of this n, right? In the first and last condition are same but reverse order, right? In the initial condition, right, I differentiate u n times and v as it is. In the last, u as it is and nth derivative of v as it is, right? In this way we can find out our problem. How to, right? Question is that how to apply the Leibniz theorem. I explain again. Suppose I have a function, right? This is the function, and how to apply Leibniz theorem n times, right? What is the meaning of y2? Y is the function of x and y2 means second derivative of y. What is the meaning of y1? Y1 is the first derivative of y here. So how to apply Leibniz theorem in all these things in circular part? How to apply? So first of all I apply in this part, right, and then this, and after this I explain again, right, by using the Leibniz theorem n times. How to? So first of all I write here nth derivative of these terms, right? First of all I apply here y2 is as it is, but question is that how to recognize that which will be u and which will be v. I explained in the previous lecture and I recall just now. V will be function whose differentiation goes towards 0. Suppose I write here two function y2 and 1 minus x square, right? 1 minus x square differentiation 1 times as it is I write here, right, and differentiate of 1 minus x square I write here minus 2x, and differentiation again 1 minus 2x square minus 2. So that means 1 minus x square will be v and another function y2 will be u here, right? So in this student keeping in the mind when we solve the problem, right, it play the most important role, right? y2 and 1 minus x square as it is I write here, and y2 as it is, and n minus 1 divided by 2, this is the part of Leibniz theorem, and second n minus 1 2 derivative of y2 and second derivative of those. So this is the part of this part, right, this is the part of this part. So in this way we can apply in the this part. How to apply, right? So I apply here, I applied nth derivative of y1 x as it is, right, n minus 1 derivative of y1, right, and differentiation of x is 1, and m square is the constant and derivative of y is yn, right? Now after this we solve the problem. What will be the answer of these terms? I explained in the previous lecture, both are sum. How to sum? So sum will be yn plus 2 here, right? 1 minus x square is as it is, and what will be the answer of these terms? Both are add n minus 1 plus 2, right, n plus 1. So I write here n plus 1. In the same way minus 2x minus is outside, n minus 1 2 is cancelled out by 2, and what will be the answer of these terms? So answer of these terms will be yn, right? Answer of these terms be yn plus 1 here I write here, and answer of these terms is yn, and answer of these terms is yn. So in this way, right, we compile our result with the help of Leibniz theorem. How to? Now question is that what is the role of such type of things, right? I resolve this part. This is the common part and there is nothing yn plus 2 only one times. N plus 1 is there, n plus 1 is there, both are combined together because I want to check here like terms with together. So there are both together, right? N both are together. So what will be the summarize of this result? The summarize of this result will be here this, right? Now I explain again it very shortly, and student can be do direct if they have practice, right? Why? Suppose by using this practice we can write only this direction. How to? Right, nth derivative of y2 n plus 2, this is as it is complete, and after this n plus 1 I write n plus 1, and differentiation of this is minus 2 I write here minus 2, minus n minus 1 upon factorial 2, and differentiation of this minus 2 is 2, so 2 can by cancel out, remaining portion is this. So that means this is portion completely directly without any calculation if student have the practice, right? Now this, what is this, right? Now suppose I want to calculate this, so x y1, so what will be the nth derivative of this? N plus 1, so I write n plus 1 x as it is, right? Differentiation of x is 1, and n minus 1 derivative of is y, n minus 1 derivative of y1 will be y1 yn. So in this way we find the all things here and use the directly. So student keeping in the mind, this is very most important problem when we solve the different problem in future. So this will be help all of us, right? Now next is, right, next example, if y is equal to this, so there are two function x into log 1 plus x, and our aim is differentiate n times, right? So how to apply n times Leibniz theorem directly without any hesitation, right? So how to apply here? So I apply here Leibniz theorem, I write here, right? What in which will be v and which will be u. So differentiation of x one time is as it is, and next time differentiation is 1. So that means x will be v and log will be u here. So I write here nth derivative of log 1 plus x, nc1 means n, student can be use nc1 and student can be use only n, right? So in this place I write here. Now question is that what is the nth derivative of log 1 plus x, right? So I explained in the previous lecture, minus 1 raised to the power n minus 1 factorial n minus 1 upon x plus 1, right? In the same way I write here in this side. So in this way we can use our problem, right, and use the result. In this way another problem is, that is very most important problem, if y is equal to this, right, there are two function, one is x raised to the power n and another is log x, right? Then prove that this result. So what will be the meaning of this result, right? Because how to detect that, how many times differentiate we do here, right? How to, so I recognize here n plus 1, that means I differentiate n plus 1 times, but how to? First of all I calculate y1 here with the help of this y, right, and after this I apply n times Leibniz theorem, then result will be automatically n plus 1. Suppose I wants to apply Leibniz theorem n times, so what will be the result of these terms? So result will be n plus 1. Student keeping in the mind and understand very carefully, when we solve our problem, so with the help of proof we can recognize what we can do here, right, very clearly, right? So suppose in proof there will be yn plus 2. So what will be our roadmap of to solve the problem? First of all I calculate y1, then y2, and then apply Leibniz theorem n times. So this is very most important, right? How to apply the Leibniz theorem n times. Always we try to apply the Leibniz theorem only n times, right? So how to use solve the such type of problem? So this is the given condition, right? And there are two function x raised to the power n into log x. So suppose I wants to calculate y1, that means first derivative of y with the help of product rule. So what will be the product rule? X raised to the power n as it is, and differentiation of log x is 1 upon x, I write here, right? And differentiation of x raised to the power n minus 1, right, and log x as it is. That means I apply here simple product rule, right? Now x raised to the power n minus 1 can be written in the form of x raised to the power n upon x, I write here, right? So that means what is the benefit of such type of problem? So student always keeping in the mind, when we solve the first derivative, so we try just reduce it into previous form. Previous form means in y, right? How to? So there is x raised to the power n minus 1, so I write here x raised to the power n upon x, right? X raised to the power log x is here. So what will be this? So this will be y here, right? So in this way we change the given problem into previous form. Previous form means given original problem. So x is common here and x is multiplied by this side. So what will be the result of x y1, x raised to the power n, x goes to this side n, or this is equal to y, I write here, right? Now we differentiate here, right, again by using Leibniz theorem n times. Why? Because our aim is calculate here yn plus 1, and right, I differentiate 1 times, right? So remaining portion is n. So I apply Leibniz theorem n times. So what will be the result? I write here in the first form, right? Now I explain briefly, right, but after this I calculate direct, right? So dn xy1, dn xn, and this, right? So first of all I apply in this case Leibniz theorem n times. So what will be the result? dn y1 x as it is plus n is the part of Leibniz theorem, that means n minus 1 derivative of y and differentiation of x is 1, that means Leibniz theorem finish, right? What is the result of these terms? So, right, I explained in the previous lecture, if both are same, so result will be factorial n, right? And what will be the result of this terms? The result of this terms will be yn here. So in this way we can calculate each and everything, right, in minimum time. So when student have the practice and familiar to the such type of problem, they can solve easily by one step, right? Now what is the answer of this terms? The answer of this terms will be n plus 1. X is always right outside the this terms. And what will be the answer of this? So answer of this will be yn. So nyn, and right, so this is the factorial n and nyn, and nyn is cancel out and factorial n goes to this side and divided by x. So we got the our proof. This is the our proof, right? So in this way we find out the our proof, right? We solve the given problem till then we got the our proof, right? This is the phenomena of this problem. In this way we find the solution of such type of problem. Student keeping in the mind, when we solve the problem, first we see the proof. With the help of proof, right, suppose I write here n plus 2, so first of all I calculate here y1 till now and differentiate again, we get y2, and after this apply the Leibniz theorem n times. So student keeping in the mind very carefully when we solve the problem. This is the another problem. What is the problem? The problem is this, right, y is equal to x square minus 1 raised to the power n, and prove that there are two things. How to prove? The first is this, right, and second is this. This is nothing, this is the part of the first proof. This is very easy. So first question is that how to start this? So there is n plus 2, there is n plus 1, and there is n. Which is the largest part, the largest derivative? So largest derivative is yn plus 2. So what will be the roadmap to solve this problem? So roadmap will be here. First of all I calculate y1 with the help of this. First of all I calculate y1, then y2, and then apply Leibniz theorem n times, right? So this will be the roadmap to solve this problem, right? How to I discuss here. First of all I write y here. What will be the y1? So this is the algebraic function. Student study the formula in 12th level. So n is outside, x square minus 1 raised to the power n minus 1, and what will be the differentiation of bracket? X square minus 1 is 2x. So I write in the form of y, because n raised to the power in numerator and x square minus 1 is denominator, and this will be equal to y here. So what will be the answer? 2nxy, right, and remaining portion goes to in left hand side, and this will be here x square minus 1 into y1, that is the part. Now differentiate again with respect to y, with respect to x, because our aim is not complete. Our aim is reduce first y2. So how to apply? I apply here product rule. I apply here product rule. How to apply product rule? So differentiation of y1 is y2, x square minus 1 is as it is, right? Now next differentiation of x square minus 1 is 2x, and y1 is as it is equal to, now apply product rule this side. So 2ny and 2nx, a differentiation of y is y1, I write here, right? In this way we find out differentiation of x is 1, so I write here 2ny. So in this way we find out our problem. Now we get y2 here. Now what is the aim, right? Now what is the motive over? Now differentiate n times by using Leibniz theorem here. I apply here Leibniz theorem. In which terms? In this terms. So first of all I write here Leibniz theorem without any calculation directly. So if I apply Leibniz theorem in y2 n times, so what will be the result? So result will be yn plus 2, I write here, and this is as it is, right? Now next one less, so result will be yn plus 1, and differentiation of x square minus 1 is 2x, so I write here 2x, and n is the part of Leibniz theorem. n minus 1 upon factorial 2 is the part of Leibniz theorem, and differentiation of 2x is 2, right? And one differentiation is less, n plus 1 less is yn. So right, so starting from n plus 2, 1 less, and then 1 less, so v goes to yn. So this is the complete part of this part, right? Now how to apply in second part? So how to apply in second part? In that means this part 2x1. So I write here 2x as it is, and what will be the nth derivative of y1? yn plus 1, I write here, right? Differentiation of 2x is 2, and n is the part of Leibniz theorem, and differentiation of n minus 1 terms of y1, yn. So this part is complete. Now similarly apply this part and apply this part. 2n is constant and this. Now our aim is, right, two like terms are together. So yn plus 2 is here, right? 2n plus y 1, 2 and 3 both are together, so I write here, right? Yn is this, 2 cancel out, right? This Yn and this Yn are together, so what will be the result here? So 2n is 2n cancel out, right? To minus 2n square, n square, minus n, minus is common, n, so this will be the our proof here. So we use our proof part always, right, and solve the further. And what will be the position of these terms? This is nothing, right? Suppose I divided minus 1, so what will be the result here? 1 minus x square, right? Yn plus 2 here, right? In this way we go to this result, and in the place of dn xn I write here tn, so we got this result, right? So in this way we find out the problem of this result, right? So in this way we find the problem of our, we consider the another example, that is very most important example. Y is equal to log x plus under root 1 plus x square raised to the power 2. Prove that result is given here. Yn plus 2, 1 plus x square, 2n plus 1x, yn plus 1, n square, yn is equal to 0. This is 0 here, right? Now question is that how to start such type of problem? So write n plus 2, n plus 1 and n. So largest derivative is n plus 2. So roadmap of to solve this problem will be here. First of all I calculate y1, then I calculate y2, and then apply Leibniz theorem n times. This will be the roadmap to solve this problem, right? I recognize from here, right? So in this way we find out the solve of our problem. How to solve? So this is the given condition, right? Suppose I wants to calculate first y1, that means first derivative of given problem. So how to calculate? This is the power of 2. So first of all I explain the algebraic function. So 2 outside and power will be less than 1. So log as it is, right? What will be the differentiation of log? So differentiation of log will be 1 upon x, and what will be the differentiation of log x plus 1 plus x square under root x plus, so this will be the 1 upon this, right? Now question is that what will be the differentiation of this? So x differentiation 1, and what is the differentiation of under root 1 plus x square? That is very most important differentiation, right? So 2x upon 2, right, 1 plus x square, so 2 will be cancel out here, right, and this goes to this side, and what will be the result here? So result will be here, right, this goes to this side and plus x, this is the result, and upon under root 1 plus x square, this goes to this side, and these terms are remaining terms are same. Student keeping in the mind when we solve the problem, right? In this way we got this result, right? Now question is that there is under root 1 plus x square. In proof there is only 1 plus x square. So how to remove it? So that means v squaring on both sides, right? This portion is cancel out here, right, and squaring on both sides. So what will be the result here? So result will be here y1 square 1 plus x square, and 2 will be 4, and this will be square here, right? So what will be the answer of this? So answer will be this y, because this is the given. So I recall just when we solve the first time and get the first derivative, so after this we convert the previous form means y, so I convert into y. Now first of all I differentiate again, because our aim is calculate here y2. So how to calculate? To differentiate, I write here differentiate again with respect to x. There are two functions, first is y1 square and second is 1 plus x square. So how to differentiate this? Student understand very carefully this portion. So what will be the answer differentiation? So 2y1 and differentiation of y1 with respect to x will be y2, right? So this will be the differentiation of y1 square. So I write here, right, very briefly, right, differentiation of these terms will be here. What will be the differentiation here? 2y1 y2, and this terms is as it is. Now y1 square is as it is, and differentiation of these terms is 2x, right, and differentiation is 4y is equal to 4y, y1. So in this way we find our result of by this way. But question is that how to solve the such type of problem in further way? How to solve? We discuss it, right? So in this way, first of all we see here 2y1 is the common part. 2y1 is a common part. When we take the common part of y1 here, so what will be the result here? So result will be here this, right? Now apply Leibniz theorem how many times? So I got here y2 and I want to prove this. So that means Leibniz theorem apply n times. So I write here applying Leibniz theorem n times. So in this way we apply Leibniz theorem direct without any calculation. So what will be the result here? So result will be here by using Leibniz theorem n times, right? What is the differentiation of y to n times? yn plus 2, this is as it is, right? Now plus 2x, differentiation of this term is 2x, I write here, n is the part of Leibniz theorem, and what is the n minus 1 differentiation of y2? yn plus 1, and after this n minus 1 upon factorial 2 cancel out, so this will be yn. So that means this is the complete part of the previous part, this, right? Now what is the part of this part? x y1, right? So x as it is, and what is the nth derivative of y1? yn plus 1. What is the n minus 1 derivative of y1? yn, and differentiation of x is 1, right? Differentiation of 2 is 0, so I don't write here, right? So in this way we find the direct without any calculation, right, this portion and get our result. Now we discuss that this and this are the like terms, right? So both are merged, right, together. So I write here the final result, which will be proof and which will be our result. That is the most important part of the question. So student, keeping in the mind when we solve the such type of problem, so first we create a roadmap to solve the problem by seeing the first attempt, right? When we see the question, then we take the decision how to solve such type of problem. So this will be foolproof by using the practice day by day, right? So in this way we can find out the another problem that is very most important, arises in the many times in exam, right? Y is equal to this, right? And show that first is this and after this. So this is simple and easy. First of all we take the decision here, right? Suppose there will be n plus 3. So first I calculate y1, then y2, then y3 and apply Leibniz theorem n times, right? But there is n plus 2 here. So roadmap will be the first calculate y1, then y2 and then applying Leibniz theorem n times. So this will be the roadmap to solve this problem. So first of all I calculate here y1. So what will be the, this is y, and what will be the differentiation of this, right? So cos differentiation is sine log x is 1 upon x plus b sine cos x log x, and differentiation of log x 1 upon x, right? So x is goes to this side, the result will be this here, right? But this part not a y, right? And our aim is differentiate again, because our aim is calculate y2 first. So we apply here differentiation 1 times and calculate the another result. What will be the product rule here? So differentiation of y1 y2 x as it is, y1 as it is, differentiation of x is 1, right? In the same way I write here minus sine minus a as it is, differentiation of sine cos log x as it is, log x 1 upon x, cos x differentiation minus sine log x, and log x differentiation 1 upon. I apply the chain rule here, differentiation, right? Student study in the 12th level. There is no need to explain, right? That means x part is common, goes to this side. This will be x square and x y1 here, right? And this will be again y. So I write here minus 1. So in this way, right, we try to change in the first derivative. If not possible, so we change in the second derivative. So we change in the second derivative y, right? This is y, and y goes to this side. So this is the result, our proof. This is our first proof, right? Now question is that how to get the second result, right? So there is a hint. If we apply Leibniz theorem n times in this procedure, so we got this result, right? This result I prove here, right? So I apply the Leibniz theorem in this part n times, right? So first of all yn plus 2x square as it is, n is the part of Leibniz theorem, right? And the differentiation of this yn plus 1 x 1 plus x square 2x, this is the part of Leibniz theorem, 2 cancel out y, and we got the result here, right? Like terms are together and solve the result. In this way we cancel out x and cancel out, and we got the result in this way. This is the result. So in this way we find out our result to calculate each and every problem. So student, be very careful when we solve the such type of problem. So first we prepare the roadmap of the such type of problem, and this is very most important problem. This is the another things, but each and every problem solved in the previous method. There is nothing is new, right? Question is that y is equal to this, and question is that yn 0, right? So roadmap will be the solve of such type of problem is always the previous. First we calculate y and y0, right? Then calculate y1 and y1 0. So in this way we find out there the given problem is right here y is equal to m cosine, right? So first we calculate y0. What will be the y0? That means in the place of x I write 0 here. So what will be the new result? So result will be sine inverse 0, sine inverse 0 0. So result will be here y0, and y0 is equal to 0. That is very most important part, right? In this way we find out y1, that means first derivative. How to calculate first derivative here? So what will be the differentiation of sign? So differentiation of sign will be here cos, I write here cos m sin inverse x, and differentiation of sin inverse x 1 upon under root 1 minus x square. Student study in the 12th level what is the differentiation of sin inverse x, right? So I write here. Now our aim is putting x is equal to 0 in whole terms. So what will be the result of y1 0? So I write here y1 0, right? So value of 1 minus 0 1, sin inverse x 0, and what is the value of cos 0? 1. That means result is m. So I write here. So in this way each and every step when we calculate our derivative, so hand to hand we calculate x is equal to 0. That is the our part, because our aim is yn 0, right? And we solve the previous problem, right? Now next, what will be the solution of such type of problem? So 1 minus x square goes to this side and this will be this, right? This is not conversible in y. So y we here, so first of all I explain here squaring on both side, and if squaring on both side, so square root is finished here, and m square cos square y, and is cos square y can be written 1 minus sin square, because our aim is reduced into sin here, because sin in y, right? So how to recognize here? So what will be the value of here? So value will be here y1 square 1 minus x square m square, this is 1 minus sin square, and sin square is y square, so this will be 1 minus y square. Student keeping in the mind very carefully when we solve the problem, right? And suppose we differentiate this, so what will be the differentiation of y1 square? So differentiation of y1 square will be 2y1 y2, right? I explained just now. And 1 minus x square is as it is, minus differentiation of 1 minus x square minus 2x, right? And y1 square is as it is. Now this is m square is as it is, and differentiation of 1 minus y square, 1 is 0, and differentiation of y square is 2y y1. So in this way we solve our problem, right? Hand to hand, and taking common, the 2y1 is common in whole part, right? So what will be the remaining terms? The remaining terms will be y2 1 minus x square xy1, and this goes to this side will be m square y. Now with the help of these terms I want to calculate y2 0, that means putting x is equal to 0 in whole terms. So what will be the result here? The result will be y2 0 1 minus x 0 1, this terms is 0, m square y goes to this side, and y0 will be here, this y0 will be 0 here, right? So that means y2 0 will be 0 here. So in this way we calculate each and every derivative at the particular point x is equal to 0. Now applying Leibniz theorem n times, because method is not different. In the previous question I applied this method, in this question apply this method, so phenomena will be same always, right? So how to solve? That means I apply Leibniz theorem in this part. So what will be the result? I explained just now and proof the complete part. So this will be the result over complete result part, right? Like terms together always. So if we collect the like terms here, so what will be the result here? So result will be this, right? Suppose I want to put it here x is equal to 0, right? So what will be the result here? So suppose I want to here 0, so 1 minus x square, this will be yn plus 2, and this will be complete 0, because multiply by 0 is always 0, right? So result will be minus. So what will be the result here? We see here very carefully. So result, this is the previous result. Suppose I want to put up x is equal to 0 here, so what will be the result here, right? So this is right here, I write here 0, right? So this goes to this is part of this, right? This will be 0 here, because putting x is equal to 0 here. So what will be the rest? This goes to this side and result will be yn 0, right? So now question is that how to solve further implement. So first of all I calculate here n is equal to 135, that means odd particular case, first derivative, third derivative and fifth derivative, and go to the result, right? y3, suppose I write here y3 0, I write here 1, so what will be the result? y3, and I write here 1 square minus what will be the y1 0. So y1 0 is the m in the previous part, I calculate it, right? And what will be the result of y4 0? In the same way I calculate here, right? So in this way we find out the all derivative at a particular point here. So what will be the, I write here 2 4 6, suppose I write here 2, so what will be the value of 2 here? So result will be here y4 0, and y4 0 is depend on the y0, right? Because suppose I write here 2, so 2 square minus y2 0, and what is the answer of y2 0? y2 0 is 0, I calculate in previous part. So in this way we find our problem with the help of this, and this will be the final answer to write our problem, right, for the odd is one place and all even are one place. So in this way we find our problem in this way, right. Suppose I have considered the another problem that is very most important problem and arise in the GATE exam many times. So how to solve this problem? So this is y is equal to this part, and how to solve, right. So first of all I calculate y0. Y0 is the important part. This arises in the GATE exam. What will be the y0, right? So y0 will be cos inverse 0, and cos inverse 0 will be pi by 2. So I write here e pi by 2. In this way, first of all I want to calculate here y1. So what will be the y1? Y1 means first derivative. How to solve first derivative? So minus e raised to the power m cos inverse x, and what will be the differentiation of cos inverse x? Minus 1 upon under root 1 minus x square. Student studied in the 12th level, right. Now this part goes to this side, right. So this will be this, and remaining this will be the y here. So result will be my here. Result will be my. Now I want to calculate y0, putting x is equal to 0 in this part. So what will be the result? y1 0, 1 minus 0 1. So I write here minus m y0, and y0 value of this. So right, value of y1 0 will be minus m e raised to the power m pi by 2 here, right. So in this way we find out our problem to solve the different problem, right. In this way we find out our y1 square. This is the way. Now differentiate again with respect to y. Why? Because our aim is calculate first y1 and then y2 and then apply Leibniz theorem. So in this way we find our result 2y1 y1 y2 1 minus x square minus 2x y1 square m square 2 y1 y2, right. So in this way, taking common 2y1 part, right, what will be the new result? So result will be this here. Suppose I wants to calculate y2 0 here. So how to calculate? Suppose I write here x is equal to 0. So what will be the new result? y2 0 1 minus 0 1. This part is complete 0, and this goes to this side m square y0. And what is the value of y0? Value of y0 is this. So what will be the value of y2 0? I write here m square e raised to the power m pi by 2. Right. So in this way we can find out our problem to solve the problem. In this way we can solve our problem, right. How to? By using the Leibniz theorem, applying the Leibniz theorem n times. In this way we can find out our problem. So in this way we get our result by using the such type of result. So in this way we can find out our result yn 0 n minus 2 and calculate the problem. In this way we can solve such type of each and every problem. And another problem is this: with the help of Leibniz theorem we can solve, and the student can take the practice problem, and with the help of first I calculate here this is y and calculate here y1, and first try to solve the in previous form. How to? Squaring on both side I got this problem. Now right, now apply Leibniz theorem n times and get the result. This will be the result over by applying Leibniz theorem n times, and now putting x is equal to 0 each and every stage, right. We get y0. I suppose I write here what will be the y0 here, right. So y0 will be 0 here, right. We can calculate here what will be the y1 0 here, right. So y1 0 is equal to also 0, right. So I write here. So what will be the result of this terms? So we can calculate each and every terms by using the result here. So in this way we find out. Suppose I wants to calculate here what will be the y2 0. So I calculate y2 0 will be 2 here. So I write here 2. Right. In this way we can find out each and every problem. Now today we discuss the some other problem, right, arises in the GATE exam. This problem arises in the GATE exam in 19, right, in each and every branch, approximate computer science and EC, right. So how to solve the such? What is the meaning of such? Suppose y is equal to this. So what will be the yn? That is very most important and interesting problem, right. How to? We consider here y is this. Suppose, right, so I write here a very most important result. Suppose I wants to calculate here x minus 1, right, x raised to the power n minus 1 divided by this terms. So how to divide first of all? Because I wants to calculate first of all is degree. What will be the degree of these terms? If I calculate exactly degree of these terms and differentiate n times, so I can solve it in 10 seconds, right. How to? Right. So suppose divided by x raised to the power n minus 1. So I write here x raised to the power n minus x raised to the power n minus 1, right. This minus and this plus, this cancel out. This will be n minus 1 here, right, and minus 1 here, right. Next time when I divided it, so this will be x raised to the power n minus 2 here, right. So in this way when we divide our problem, right, so we use the different polynomial, but in this case when we divide, right, I write again x raised to the power n minus 1. So result will be x raised to the power n minus 1 plus x raised to the power n minus 2 dash dash dash. That means there exists a polynomial of degree n minus 1, right, and I want to calculate nth derivative of a polynomial whose degree is n minus 1. So I explained that previous lecture a most important result. If d n, right, and there is x minus 1, that means derivative power is large with respect to the power of a degree of a polynomial. So result will be 0 here, right. So in this way, suppose I want to calculate, this is a polynomial of degree n minus 1, this y is a polynomial of degree n minus 1, and I want to calculate nth derivative of this polynomial. So result will be 0. Very most important and interesting result is here, right. So in this way we can solve our problem by using the different example. This is another problem arises in the gate. If fx is equal to 10x, what will be the value of these terms? But I write here proof here, right, I write here proof, right here how to solve this problem. So this will be sin n pi by 2, sin, I write here sin n pi by 2, right. So what will be the result here, right. So we see here very carefully, given tan x can be written in the form of sin x upon cos x, and cos x goes to this side, and apply the Leibniz theorem n times, this is y and this is cos x. So how to, in this case anyone may be v and anyone may be u, because there is nothing to change the reduce the towards the 0. So I write here first one part, second part and third part. Now putting, right, nth derivative of sin x, nth derivative of sin x I write here, right, in the previous lecture I explained it. So in this way we got, putting x is equal to 0, so we get the result here, interesting result, this will be is equal to sin n pi by 2. So in this way we can solve our problem arises in the gate. I hope today lecture student have the some gain, right, due to the some problem arises in the different competitive exam just like a gate. If student have any problem today lecture, so they can be contact me, I will try to solve their problem. Thank you. Jai Hind.